microservices testing and some of the things that can, if you're lucky, go right, and some of the things that can go horribly, horribly wrong. So I'm Holly Cummins. I work for Red Hat. I've been with Red Hat for about a year. Before I was with Red Hat, I was with IBM for 20 years. Obviously, I was there for 20 years. I did a lot of things, but one of the things that I did was I was a consultant. And I ended up doing a lot of firefighting. So I'd sort of, go into a troubled project, and then I'd try and figure out why it was going wrong. And one of the first microservices projects I did, it was in Dallas. And so I sort of got off the plane in Dallas, and my feet had just sort of touched the ground. And they said, every time we touch one microservice, all of the others break. And I kind of thought, Now, I'm fairly sure that in the microservices manual, it doesn't say switch to this architecture so that every time you touch one microservice, all the others break. I'm fairly sure it said it was supposed to work the opposite way. So what's going on? But then what I found was that I kept seeing this pattern over and over again, actually. It wasn't just this one troubled project. This was something that just seemed to keep happening. And so then the question is, well, why is this happening? How do we stop it? What do we do instead? How about you?
Yeah, so my name is Eric D'Andrea. I work for Red Hat as well. I've been here about 4 years, but I spent most of my career in financial services as a software engineer. And in financial services, at least the ones that I worked for, things tend to move pretty slow. So as we were trying to figure out this whole new microservices thing and how to test them, anybody ever fallen into the trap where, everything's got to be coordinated and done in an end-to-end test environment, like the third weekend of literally the third weekend of every month, or the third weekend of the first weekend of the second month of every quarter, or some ridiculous schedule like that. They're trying to get
fifth Tuesday of the month.
Yeah, the fifth Tuesday of the month. Yeah, someone said that to me yesterday. I was like, wait, fifth Tuesday? It just kind of in one ear and out the other. I didn't get the joke, but so definitely have a lot of experience, not necessarily as a tester, but more so as a developer with the frustration of, why do I have to align everything? Everything's supposed to be able to be deployed independently. Why do we need to align the stars, the universe, the tide's got to be just right in order for someone to sign off on a checklist for things to roll out into production?
And more generally as well, both of us, this isn't a Quarkus talk, but both of us, I'm a developer on the Quarkus team, so I help build Quarkus, and you also know Quarkus super, super well.
Yeah, I do a lot of talking about it, so if anybody, I have another talk coming up today, 1:30, same place. If you're interested, if anybody's familiar with Spring, someone's heard about Spring before.
Spring what?
So if you're interested in learning about Quarkus through the lens of someone who's familiar with Spring, I'm going to give that talk a little bit later today.
And there is also a book.
There's also a free giveaway, so I wrote a book about it. At 2:45 today out in the Red Hat booth. We've got a limited supply, but it's always free online if you're interested in giving it a read. So shameless self-plugs all over now at this point.
But going back to what Eric just mentioned, that this is a talk about testing. I am not a professional tester. Eric is not a professional tester. I wouldn't even, not only am I not a professional tester in terms of my day job title, I wouldn't even really say I'm a testing expert. But actually, that's okay, because I think testing isn't something that you want to leave to the two QA people in the corner and the rest of us go, testing, whatever, I'm sure if it doesn't work, someone will tell me, right? As developers, testing is something that we all need to be caring about. And we do want to be getting these feedback cycles as small as possible so that we don't have to wait for QA to come back and tell us it doesn't work. And we also want to be just, professional pride, right? I want to make sure that the stuff I build works. I don't want to be delivering garbage into the pipeline and then, somewhere later on someone comes back and says, hey, yeah, by the way, it was a nice idea, but it totally doesn't work. So I think, testing is, underappreciated as a skill. Testing can be hard. And I think when you get into microservices, testing microservices is extra, extra hard. And I think it's one of the things that when we make that decision to go to a microservices architecture, we maybe don't fully think about, okay, yeah, but how are we going to test this and what's our strategy and do we actually have the right skills to do this? So this is sort of a typical net architecture diagram. Can you,
What's that?
What, okay. That was the Netflix architecture. Adrian Cockcroft called it the Death Star diagram. You can see why it really, really looks like it. And I think, it was probably sort of an unpleasant surprise when you think you're going to end up with this really nice, clean architecture, and then you actually end up with something that destroys everything around it. Although the Netflix architecture is particularly evil and Death Star looking, Twitter have a similar architecture, or they used to until recently. And less said about that, the better. We do see, this kind of complexity in microservices architecture. Sorry, I'm slightly thrown by the
audio.
Yeah.
We weren't sure if it was actually going to work. It's like one of those, yeah, we'll test it in production, right?
Yeah.
We don't do that. Nobody does that, right? You don't test anything in production.
So I think a lot of organizations, the reason that they go to a microservices architecture and the reason they make the investment in a microservices architecture is because there's this idea that everything was terrible before. But when we go to microservices, all of our problems are going to be fixed. And that's the kind of the message that goes up to like the execs. And then a while later, the execs come back and say, well, so did it solve all the problems?
Just like cloud, right?
Oh, yeah. And, it's sort of, microservices tend not to solve all problems because you think you're going to get something really neat and tidy and non-dangerous. And then what you often get is something that looks a bit like this. So it's got a lot of tentacles, and it doesn't look great sort of on paper, but then when you look at the dynamics of the system, it actually is even worse.
Kind of like Han Solo at the time he was transporting the Rathars, from, was it Force Awakens, I think it was. He was always up to make a quick buck and, do something like, oh, yeah, this will solve all my problems, and then it ends up eating people. But in the end, it actually did save him, right? Because he had the people that were going to, take him or whatnot because he didn't pay up, and it ended up eating them all. So, kind of like the story of his life.
Yeah, so when you're doing your microservices evaluation, you can have that sort of flow, right? Of like, well, we think it's going to solve all our problems. In practice, the dynamics may actually end up being a little bit bad, and it may end up eating a few of our developers. But it's okay because it will also eat the developers we don't like. And so microservices is the right architectural choice, maybe. But I think when we think about testing microservices, how many people have had this conversation with some of their colleagues, of like, when we go to microservices, everything's going to be really easy to test because instead of having to test this whole big system, I just have to test the one tiny little part of it. Sound familiar to anybody? Yeah. Couple of hands for sure. But one of the things that we see is particularly, a system like this, you're not going to have a small number of people developing it. You're going to have a large number of people developing it. And so you still do end up with this potential for misunderstanding. And I think when we start developing microservices, it seems like it's going to be easy to test because we think, oh, well, everything is decoupled, so all I need to do is test my little unit. I need to test just my little component, and then it's all okay. But the problem we see is like, in a diagram like that, most of the interest and most of the complexity is actually in the connections between the services and how they interact with each other. It's not just the little points. And so if you focus just on testing the one little point, that's an important part of the testing story. But you're going to miss a bunch of the dynamics of the actual system. And so you don't really know if the thing as a whole works And obviously from the point of view of the business, that's what they actually care about. No one comes and says, well, your part of it works great, but unfortunately the whole system failed and we've lost, millions of dollars, but well done on writing a good little individual service, right? For the business, it's the behavior of the whole system that matters.
So does that mean you can't couple things together?
Well, I mean, that's one of the sort of the things with microservices is I think we sort of imagine that because we've made this system distributed, it's going to automatically be decoupled. And we kind of think that because distributed and decoupled both start with D, they're synonyms, but it really doesn't work like that. And there is actually no such thing as a completely decoupled system. If it's a system, the parts of it have to interact with each other. That's what makes it a system. And so Kent Beck had this really interesting article a while ago, and he was talking about coupling, and he was saying we shouldn't really think in terms of oh yeah, this is completely decoupled, because it's not, because the two parts are talking to each other. What you have to think about instead is managing the coupling. So you can say, okay, I want to be maybe more highly coupled in this part because there's going to be an efficiency to that, but here I need to be quite decoupled because that's what I need for my business process. And before you can manage the coupling, of course, you have to understand the coupling. So here, as an example of kind of why the coupling is necessary, this is the pod racer. And you can see, if you just do the sort of the mental image of if that coupling link wasn't there between the two engines, how would that system work? Each part would be sort of flying all off, and you wouldn't be able to control it at all. So you need to have the sort of the interaction between them, which is what makes it propel it forward. But one of the things that we see is often that we don't understand that coupling. And we maybe think we do, but there's other things that we didn't have the conversation about. So you may remember, of course, Kreia in Star Wars Knights of the Old Republic 2, the Sith Lords. Everybody familiar with this one? Though I've memorized it. I don't know what the rest of you have been doing with your spare time. In there, Kreia says, "It is all that is left unsaid upon which tragedies are built." And that's what we see with so many microservices systems, is there was something that didn't get said about how two components, how two services were supposed to interact. And because of that, there was a failure, and it was potentially quite a bad failure.
But there's always docs, right? You go read the docs. RTFM, is that what people say? Yeah.
Well, you see, there's a problem with docs as well, which is, who here has read completely truthful documentation? No, right? The docs, they are always wrong. There's this thing, right? It's as Anakin said, you lied to me. How many other lies have I been told by the council? And how do you know that you even have the truth? And that's what happens with docs. It's we write the docs really sincerely. We think they're correct, but actually they're just a pack of lies. And so we had this actually when we were preparing this demo. I had a bunch of code, and I handed it over to Eric, and I said, "Look, here's an awesome demo. It works great." And
on your machine.
Yeah. Then the next day, Eric came back to me and was like, "This thing doesn't work at all." And I was like, "What do you mean it doesn't work at all?" And then we realized that in the README, there was about 6 steps that I just kind of forgotten because they were obvious to me. And there was environment setup that was on my machine and no one else's machine.
Well, plus two, as soon as you put pen to paper with the way technology works, it's out of date, right? I mean, I wrote a book, it's out of date, the day it was published. It's okay, yeah, great for the last 9 months, now it's already out of date.
And so I think it sometimes seems, and particularly perhaps to management, it seems that the solution to getting the good understanding of the coupling in the microservices is that you just need to write more documentation. And if the problem is that the documentation isn't good enough, you just write more of it. And when I started at IBM, which was, as I said, 20 years ago, it was a different era. But my first project, we wrote a 500-page design document. And the first day I started coding, and we spent so much time on this design document, we were discussing where the semicolons went and the spelling and everything. The first day I started coding against it, it was wrong and my stuff didn't work because the design doc was wrong because it was, a classic, is this 0 indexed or 1 indexed, and it was wrong in the doc. So like, I think, although it's tempting to say, oh yeah, we just need to document more and that will solve all our problems, it's really, really not the answer. And I think, particularly because many of the truths that we cling to depend on our viewpoint. So what seems to be true for me, or what seems to work on my machine, when it gets out into a different environment, it doesn't work. And so really, like, the thing that you just have to do is you have to try it out. You can't just rely on reading the documentation and writing your service and hoping everything's going to work, because it's not. So then the question is, okay, if I know I need to try out at least, some of the interactions or maybe the whole system, how do you do that? And that's where you get into microservices testing. If you're going to do microservices, you have to get really good at testing, and you have to get good at automation, both for the automating the tests, but then also in general, like standing up these environments that are really quite complex. So how many of you have heard of the test pyramid? Yeah, about half of you. I think people argue back and forth about the test pyramid and like what the ratio should be, and should it be a test pyramid or should it be like a test balloon or that kind of thing. But I think it's quite a useful sort of framework for thinking about how we want to allocate our effort for testing and what we're going to get out of each kind. So at the top of the test pyramid are end-to-end tests. These are really good because they give you such a lot of confidence that the system actually works. So they're highly realistic, they're valuable because of that, but they're really, really expensive to write, and they tend to take a lot of maintenance. So you do want these, but you don't want very many of these.
That's the 5th Tuesday of every month, right?
Yeah. And then like at the bottom, you have unit tests. Unit tests, we should have a lot of. They're cheap to write, they're cheap to run. The only problem with unit tests is they don't necessarily give you that much confidence that the system as a whole works. I think, probably all of us have had this thing, right, where the tests are so green, and then we like try it out and it just doesn't even work at all. And then it's like, how did we not notice this? How did we deploy this when the tests were green? And in the middle, traditionally, you have integration tests. So these are things that are testing the connection between maybe two parts of the system, but they're not as expensive as a full end-to-end test, but they're not as easy as a unit test.
And everybody's definition is a little different about what encompasses an integration test.
Yeah, and it's getting sort of, the line is getting fuzzier as well now, because it used to be that if you wanted to run on an application server, you would have to stand up the application server, and that would take several minutes to start. And so then that was definitely an integration test. But like starting with Spring, they had these tests that were running with the framework, but they were as easy to write and as cheap to run as unit tests. And with Quarkus, we have that as well. So we've got these tests that they behave like unit tests, but they actually test that the thing works in its environment, the thing works with the framework. So that line is definitely getting fuzzier and kind of wavier. But with unit tests for sure, and with integration tests to some extent, because you're not testing the whole system, you are going to need some kind of mocks for those interactions that you're definitely going to have with the other parts of the system. So normally how a mock works is that the two parties have a conversation, and we say, okay, so my code looks like this, and their code looks like this, so here's the interaction. And so instead of testing against their code, we're going to test against a mock, which means that we avoid that dependency. And then the tests pass, everybody's happy. Problems happen when what they told us their service looks like doesn't actually match reality. So although our tests are passing because we coded against one API.
The docs, right?
Yeah, it's exactly back to that thing of like, you told me lies. Everything you told me was a lie. And you thought it was true, which is the worst part. So, reality is broken even though the tests are green. And with mocks, it's a little bit like when Luke and Han, they sort of disguise themselves as stormtroopers, and it kind of works, and they're kind of good enough as stormtroopers, but like it only gets them so far. Ultimately, they're not as good as stormtrooper as a real stormtrooper, because how could they be? They're fake stormtroopers, and then they end up in the garbage because it all goes wrong. So again, hopefully with mocks, you don't quite end up being crushed in a pit of garbage, but you can end up with sort of similar functional issues. So we're going to do a demo now and show, again, some of the ways in which unit tests can go wrong with mocks.
I guess before I said, does that like resonate with people? Like, seems to be what's going on in your organizations, or at least you've been in an organization that kind of seems what's going on here. I'm going to bring in the next. All right, so what?
Yeah. Yeah, like I think sometimes mocking can be, I have this conversation often. Yeah.
What are you actually testing at that point?
Yeah, and like I think sometimes I've written a test, I've written a thing and it works, and then I'm like trying to do the mock, and I spend like a day and a half doing the mock, and the test is that it's a slightly different issue, but the test is broken because I can't get the mock right. And actually, I could have just tested against the real thing, and my unit test would have been less pure. It would have been less of a unit. But like I could have been fixing other functional issues instead of spending the time mocking. So I think like I always try and balance it. So like if it's really cheap to mock, and if it's kind of expensive to run against, and there's not much risk of something going wrong in the interaction, then maybe I'll mock. But if like the thing that's going to go wrong is in the interaction, then I'll either try and run against the real thing, or do something else, which we'll come on to.
Yep. So we got this demo here. So what we're going to show is, if everybody been in the situation where you've got a bunch of services, all their CIs are green, all the tests are good, integration tests are good, you deploy it, and all hell breaks loose. So your phone's ringing. It's like, what happened? All the tests are green. So let's kind of show how that might work. And it's somewhat of a trivial example, and Holly and I had a conversation about it way back. It's like, dude, would this really actually happen, or are we like contriving something simple for like audience-driven development? Like what we're going to do here. And come to think of it, we actually did come across this in reality once. So this is based on my experience as well. Yeah.
Because Eric kept saying like, this would never happen. No team would be that stupid. And I was like, no, honestly, my team was that stupid.
So we're gonna.
Shall we make it a little bit bigger? Yeah.
Bigger?
Cool.
All right. So we're gonna sell some Wookiee carpets here. So pretty simple. What color carpet? So I'm gonna order a brown carpet. And what happened? We're microservices, so we got to run all the services, right?
We're here starting to see like the challenge of microservices testing. The first thing is that like you have to stand all these things up just to like run it, which is annoying.
Yep. And you see with Quarkus, it starts up, and it actually ran all my test suite here. So all my tests are green. So I come back. Okay, so now I've got from my shopper service to my knitter service. And what happened? I ordered a brown, and we don't have any Wookiee fur. So we got to go get our Wookiee fur service here.
Time to stand up another service.
Got to go stand up another service. So this service is going to start up. Again, it's up. All my tests are green. Come back over. Let's try this again. Now I can order a brown, and it goes off the screen. So I have to make it a little smaller. So now I've got an order. It goes to the knitter. The knitter says, hey, I need some Wookiee fur. Go shave me a Wookiee. And the tamer actually survived. I don't know about you, but Wookiees really don't like to be shaved. They kind of put up a fight. And so sometimes you have to downgrade the SLAs of the services because you start to lose some shavers in the process. So now we got a brown color. We got a nice brown carpet. Excellent.
Awesome.
So let's go in and let's fix something. I like to tinker and fix something. So obviously, if you can't tell, I'm from the US, she's from the UK, right? This just really bothers me. Like color with an OU,
it is the correct
It really
spelling.
bothers me.
It is the correct.
Yeah, we're here in the US, so I'm going to just go ahead.
It's called English.
Yeah, it is English. I speak English. Oops. So I'm going to just go ahead and fix that. My keyboard shortcuts aren't working. Why aren't my keyboard shortcuts working? Yeah, seriously, my refactor keyboard shortcuts aren't working.
It just goes to show that in a demo, like, no matter what, something can go wrong.
So I'm going to refactor, change it to color. All my tests are still green. Yep, so you picked it up to change. All my tests are still green. So I come back, and now I'm going to order another brown carpet. But what did I get? I got a totally indescribable carpet I did. So what happened here? So we asked for color, we asked for brown, and when the tamer, and actually this time the tamer didn't survive the shaving, but he sent back the color, and you can pretty much see it's
still brown.
Still brown in the JSON, but when it got back to the knitter, it's like, oh, now I just have null, and null is really never good, right? Because what does null mean? You gotta go read the docs, right? Awesome. All right, so all tests are green on both services. Here's the knitter service, tests are green. Wiki service, tests are green, but yet reality is broken. So how do we fix that?
So this is where we get to some of the things that you can do. So one thing that I'm a big fan of is contract testing. And I think a nice way to sort of think about contract testing is in terms of how you might test a fire alarm. So one way to test a fire alarm that gives you really, really good confidence that the fire alarm works is you set the thing with the fire alarm on fire. And so if it was a Death Star, then as the Death Star is burning, you hear from inside the Death Star, beep, 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 beep. And you go, this is awesome. Our fire alarm works.
Everybody got out.
Everybody got out. But unfortunately, we no longer have a Death Star. And, it's the same thing like if it was a house, right? You kind of hope that a fire alarm manufacturer sets something like a house on fire at least once to make sure it works. But normally they don't, because then they wouldn't have a house. It's a really expensive way of testing a fire alarm. So instead, the way you test a fire alarm usually is like a unit test. Although that does actually, so that is a fire alarm. It looks a bit like a Death Star, but it is just a normal house fire alarm. So you take your fire alarm, and there's a little button, and you push that button, and then it goes beep, beep, beep. So that gives you good confidence that like the speaker in the fire alarm works. It gives you good confidence that the fire alarm will beep if you push the button. But like if it was an actual fire, the scenario is not like my house is on fire, so then I go push the fire alarm button. I want the fire alarm button to just start up. And so by doing it that way, I don't necessarily have the confidence that the fire alarm goes off in the presence of smoke, which is the thing I really, really care about. I don't care about my fire alarm going off if I push the button, because fire doesn't have fingers. So I don't know if any of you have seen this, but sometimes in malls and places like, other sort of institutional places, they have this device, and it's like a long stick. And then at the top of the stick, there's this little cup, and they sort of wrap it around the fire alarm. And then they sort of push a button, and it goes poof, and it sends a little bit of smoke in, and then the fire alarm will hopefully go beep, beep, beep. So that gives you that. It's not the same as setting the mall on fire, but it does give you that confidence in the thing that you actually care about, which is if there is smoke, does it go off?
Well, in that test, they can kill two birds with one stone, because they can test people's reactions to the fire alarms as well.
Yeah. So this is a lot actually like contract testing a fire alarm, that you're testing the thing that you really care about without having to do that full end-to-end test of setting your Death Star on fire. Although you can actually, when we were looking at pictures for this, should any of you wish to set a Death Star on fire, for a mere sort of $3,000 or something, you can go and you can buy a Death Star fire pit, which allows you to burn Death Stars. And I think that's a little bit sort of like contract testing, sort of. So in terms of the test pyramid, when you think about it, instead of having that integration test layer, you've got a contract test layer instead, which gives you almost the same confidence as the end-to-end tests, but sort of with the cost of the unit test. So it's kind of the best of both worlds.
It breaks the model a little bit because it kind of spans the whole thing.
So in terms of thinking about like with your mocks, instead of having this situation where you've got the two parts and you kind of, there's not really any validation to say, does my mock match their behavior? The contract test, it sort of talks to both sides. So for the person using the service, the contract test acts as a mock. So you can run all of your tests against the contract test mock. For the provider of the service, it acts like a functional test. So it will say, okay, does this actually match what we expected? And because of that, what you get is the confidence that if our tests are green and their tests are green, then I'm pretty sure that reality is going to be green as well. And if, on the other hand, like they change their behavior, then all of a sudden, that part of it doesn't work. And so my tests might still be green, but their tests are red because reflecting the fact that reality is broken. And again, if I change how I use the service, then my tests are going to go red, even though their tests are green, again, reflecting the fact that if I deployed that system, it would not work. So there's a few different contract testing options. Probably the most popular one is Pact, and that's what we're going to show today. There's also Spring Cloud Contract. Another popular option is doing OpenAPI schema validation and then sort of using an extra bit of tooling to get you mock generation. And then, if you sort of go down that road, you can use things like Prism and Schema Thesis. We're not going to show those, and there is some limitations to that approach, which we'll talk about. So let's go in a bit more of a deep dive into what Pact contract testing looks like.
All right. So let's see, how can we fix that problem that was going to work? So in Pact speak, it has kind of its own nomenclature. The contract is called a Pact, and then you've got consumers and you've got providers. And people often get confused with terminology. I know it sounds simple, but happens all the time. Happens between us. Like, what service are we talking about? Am I the consumer? Am I the provider? So we actually came up with, developers always wear different hats. So we've actually got different hats to make it obvious who's going to be who. So I'm the consumer. She's going to be the provider. Hopefully she can type while holding the mic. We didn't expect non-lapel mics in here. So now that we know reality is broken, how would a contract test help fix that? So as the consumer here, I'm going into the knitter service, and I have a test for my resource. And like in classic fashion, we're using mocking. We use Mockito to mock the service to get our Wookiee fur, and to make it look like what we think what reality is going to be. We set up a mock. Hey, when I ask for some fur, give me some brown fur, right? And as we just saw, that test, at the unit level is green, reality is broken. So how might we fix that? So the first thing we'll do is we'll actually get rid of the mocking, because when we bring Pact in, the contractor is actually going to give us the mock to test against that actually kind of stands up this little service on the side that my app will actually make kind of live localhost requests to, and it'll serve what the contract says to serve. So in this case, I'm going to let's change my test a little bit. Hopefully my live templates work, because I don't know why my keyboard shortcuts aren't working. So I'm going to extend my test with the Pact annotation. So this is a test between the tamer as the provider, and now I can add in a contract here. And I got to resolve some imports because IntelliJ seems, even though I've done this like 5 million times in the last week, can't figure out that that's what I want to do. All right. Import, response, import here. Am I all green? Nope, one more. There we go. So I can say I've got a pact now between the knitter and the tamer that says, when I receive a request for some Wookiee fur, given this HTTP path with certain HTTP headers and a body that kind of looks like this. And with Pact, you can get as stringent or as loose as you want, both with requests and responses. So in this case, I'm saying that the body has some string type called color, and with an example value of brown. That doesn't mean that the value in the payload has to be brown. It's kind of any string, but the mock is going to serve me brown, because that's kind of what I've told it here. And it also has some number of an order number. I don't really care. When we look at the provider side, you'll see it'll actually, when the provider verifies, it'll just generate random things that match what I tell it to match. And then my response is going to be some HTTP 200 with some headers and a body that kind of looks like this with a string value with the value brown. And then I already have the test written here, so I can just add this. My keyboard shortcuts are not working for me. I don't know why. Oops, that's not the right one.
So what we're doing here is we're making that association to say, like, this is the mock that I expect this test to work with.
Yep, so this test basically says I'm going to hit my own system here, and this test is testing the contract for this contract that we just wrote, which is going to serve a mock server on port 8096, which is outside my application. And now when I save this, you see now all my tests still pass. It was actually very, really fast. But I didn't add any new tests. All I did is I changed the makeup of the test. So instead of doing like mocking, like class level mocking, I'm now talking to an external service. But what's kind of cool here is part of Pact has this centralized broker now. So like one of the next question, the logical question would be, okay, as a consumer, I generate this contract. How does my provider know about it? Like how do I share it to my provider? Do I put it in their GitHub repo? Do I put it somewhere? Well Pact already kind of has a solution for that. So I can publish this contract to a broker, as long as the internet, one of the fallacies of distributed computing is that the internet is reliable, right? So now if I come back, I have a broker that's already set up, and I'm using their open source SaaS free product here. And if I come into the contract, you say I've got one consumer that was just published a few seconds ago. I don't have any provider details because we haven't done that yet. And here's the interaction that we expect to happen with that. So now on the provider side, how do we verify that we actually satisfy that contract, right? So I don't know if there's anybody questioning like, well, hey, I'm the API provider. I'm in charge of the contract. But I haven't touched the provider yet. I'm the consumer, and the consumer is driving the iteration and the generation of the contracts in this case. And we'll kind of come back to that and talk about it because it's kind of a little bit mind-blowing for some people to understand. So do you want to do this or do you want me to keep going?
So now it's a challenge.
Do you want me to kind of...
Actually, yeah, good, that's cool. Okay, so now...
this is what I'm good for now.
So on the provider side, this contract is out there, but I need to write something that uses it. And the good news, partly because I don't have, well, because we're typing one-handed, is it's pretty easy. So what I can do is I can make a new class, and I call it resource contract verification tests. And then what I can do here is...
Not the whole thing.
Nope.
Just the class stuff in the end bracket. Oops. You gotta get the class border too, the class boundary. Just gonna resolve provider.
So you can see here, I'm saying, here's the URL of my Pact broker, a little bit of config to say like what port Quarkus is running on and that kind of thing. But apart from that, there's not much to it. So I just have a test template that says, please take the stuff that's in that contract and please verify that it all works. And you can see here what it's telling me. It's red, which is a good thing because reality is broken. So it's highlighting that problem where the color is wrong. And so if I go to my screen, then, whoops.
Yeah, you're gonna have to right click on it.
So then if I refactor and rename that, I can go back to the proper spelling. And if I refactor that, then we should see that my tests rerun and two tests.
Sometimes it just, oops, undo that. I thought it would put the focus back down there.
There. Let's just rerun it. Okay, there we go. Yeah, as expected. Yeah, it must have run it in because it's sort of running the tests all the time, so it must have run it in a slightly inconsistent midway through state. But when I rerun the tests, I've corrected my implementation, and my contract tests are green, which is exactly what we want. Cool.
And the other kind of cool part of that is if I come back to my broker now, the fact that it passes or fails, if we had done that, it would actually, the first time when it ran, it would have actually had a red X here. So now everybody in the world knows that reality is broken. So like I could come to the broker and I can say, hey, I've got this version of this service and this version of this service, and I want to deploy them in the same environment. Should I do it? And it's like, no, that's probably a pretty bad idea. You don't want to do that because it's got pretty high confidence that reality is broken at that point.
Yeah, so it's quite a good dashboard for seeing the sort of the state of your system, and also seeing who's talking to who, and so you can get, you know, almost an architecture diagram that comes out of that. So as Eric mentioned, this is called consumer-driven contract testing. The contract comes from the consumer. They define their mock rather than from the provider. One side effect of that is, as a consumer, if I changed the contract and said, hey, actually, you know what? I want this whole new API endpoint, then what would happen on the provider side is their tests would start breaking because they haven't implemented this whole new endpoint. That can be a challenge for some teams. It can be actually quite a challenge for some teams, because I think, again, you know, when we go to microservices, we sort of have this idea that I'm going to microservices so I don't ever have to talk to the other team again. But there is that interaction because it is a system. So you probably are going to have some discussion about the contract tests to say, hey, you know, the contract tests are failing. How are we going to fix this? Did you know that the contract tests are failing? That kind of thing. Another thing that you can do, which is really nice, is contract first. So it's like TDD, but at a system level. So the idea is that instead of the provider writing all of these endpoints that they don't really know if anybody wants, you start on the side of the consumer and you say, in order to make my thing work, this is what I need from you. And so then the provider doesn't have to implement anything more than what's in the contract. And this can work well sort of later in the life cycle as well. And this is why I think consumer-driven is a nice way of doing it, is if the provider had some endpoint, if no one was using it, they could safely remove it because the contracts that were coming from the consumers and saying what the consumers were doing would give them the information to know, hey, this endpoint isn't actually being used. I can safely get rid of it. So we mentioned that Pact has these advantages, that it is the consumer-driven model. Like anything, if not, it's often a good choice. It's not always the good choice. It does assume that the consumer and provider have good communication. So if the consumer and provider aren't talking to each other, either because they're in different companies or because they hate each other too much, then maybe that's not the right way to do it. Again, both sides, sort of by definition, have to be using Pact, and Pact is it's not like OpenAPI where it's a universal standard. It is kind of specific to Pact. So if one side isn't using Pact, it's not going to work. If you have a public API, so you can't even figure out who your consumers are, then that's not going to be great.
I want the weather to be sunny on Tuesday from the weather service. Probably don't really have much control over that, right?
Another thing that sometimes is an issue is, and we had this on a previous demo, where if the provider doesn't actually control the data that they're sending you, then there's no point having a test to say, hey, I would like the weather service. I would really like the weather to be sunny on Tuesday, because the provider is just telling you about weather that's coming from somewhere else. So, often like if it's sort of the provider is just like a pass through, then maybe Pact isn't the right solution. Another thing is that although Pact acts as a functional test, just like you want to make sure not to write too many end-to-end tests because they become a maintenance burden, you probably don't want too many functional kind of tests or load tests or that kind of thing in Pact. Another thing that people will sort of often be evaluating against each other is Pact against Spring Cloud Contract. Pact, I think, has a number of advantages. It came from the Ruby ecosystem first. It's polyglot, so there's binding for Node.js, Java, all sorts of languages. Spring Cloud Contract is an example of provider-driven rather than consumer-driven, and I think for most scenarios, consumer-driven is going to be nicer. Another nice thing in Pact is that you can do a much deeper testing. So in Pact, the provider can specify states. So that's really sort of doing a little bit of sort of environment setup before the test. So it says, it could be something like, if it's on a Tuesday, I would like this to happen. If it's on a Wednesday, I would like this to happen. So again, you can get more of that kind of deeper functional level testing.
Or if you have no data, I expect this, because you got to guard as the consumer that the provider I'm talking to is in some bad state. What that state means to the provider, I don't really care about, but there's probably a state where it doesn't have data and I need to be able to gracefully handle that as a consumer of it. So I can specify in the contract, given this state, this is what I expect. You figure out what it means to be in that state.
And another cool aspect of Pact is that Pact broker. So we just gave you like a really brief tour of the Pact broker, but you can use it to get that sort of architecture view and that system level dashboard. Another thing that sometimes will make sense to do, and a lot of people do contract testing this way, is using something like Swagger or Open API. The challenge with this, so this works really well for something like a public API where you don't know who your consumers are, but it doesn't give you that kind of deeper testing. It's just going to be looking at the syntax. So it's kind of like the equivalent of, with a mock, it gives you the type safety, but you don't really know what's going on with the behavior. With an Open API test, it's the same thing. So it would catch something like the color problem because the schema is different. But if you have something that's a more fundamental behavior difference, it might not necessarily catch that. So it's sort of this. It's looking at the syntax, but it's not looking at the semantics. So it's kind of the same as if it looks the same, even if it behaves differently, your test isn't going to catch that. So it's it's a bit like here they look like stormtroopers, but one of them is Luke and one of them is Han, and you know that because they're actually going to behave differently and they're going to rescue Leia, rather than like doing whatever stormtroopers do when they're at home.
And he's shorter.
Yeah, and well, yeah. So let's show a demo of how you can get that sort of that semantics testing with Pact.
All right, so we've got our carpets, so let's order a few more carpets here. We get brown carpets. So what color Wookiees? So there is actually an official Wikipedia. What colors do Wookiees come in? Is there black Wookiees? Let's see. Black Wookiee. Okay, I got a nice black carpet. How about a white carpet? Okay.
Yeah, that works perfectly.
Anybody have a pink carpet in their house? Maybe in the 70s, 80s, or orange, or So what happens if I ask for a pink carpet? I got a brown carpet. Oh, that's not what I wanted. So let's find out.
Yeah, but like Wookiees don't come in pink. So.
Yeah, so I asked for pink and I got brown. Well, maybe the tamers didn't survive the shaving, and maybe he or she didn't get to die. So probably I don't think there are actually pink Wookiees in existence. So somewhere along the line, somebody's gonna dye the fur. Right, so you probably take a white Wookiee, shave them, and dye the fur. But whose responsibility should that be? I'm on the consumer. That's your responsibility. I asked for fur. I should just get the fur.
And on the provider side, I am totally doing my job. And in fact, I'm doing my job. It was a very dangerous job, and I did my job. I went out, I got the Wookiee. I couldn't find a pink Wookiee, so I just did a fallback, which seemed like the right behavior. I didn't want to return you null because that would be, so I returned you the best Wookiee I could find, which was brown.
All right. So how do we fix that in our test? So we've got our contract that says, basically where I say, given any color, the mocks can give me back brown, but I'm not really doing any kind of validation on what I'm saying. I'm just saying it's just some string, and when I send you a string, I should get back something that looks like this. But what if I wanted to get more specific about that? So if I specifically request, I say, hey, instead of any string, I'm actually going to give you the color pink. And in that case, I'm going to expect back a 404 because I feel for the Wookiee tamers that they don't survive the shaving. So I'll take it upon myself to go find a dyeing service, yet another microservice that we've got to write and kind of go through all the testing processes with. But I'll take it upon my responsibility. So I just need to know that, hey, I don't have pink fur. and then I'll make a decision about that. But you see, immediately, my tests are failing.
And so Eric and I had a big discussion about this as well, because I felt that returning a fallback was the right thing to do. And Eric was like, no, actually, if you don't have the Wookiee that I ask for, don't give me like a random other Wookiee. Give me a 404 so then I can take some corrective action. So we're sort of changing the contract to say, yeah, don't give me a Wookiee that's the wrong color.
Yep. So now I just wrote a test that uses that contract and says, now my test, this test that I just wrote is failing to say, hey, when I ask myself for a pink order, I'm expecting a 418. Anybody know what 418 is? The HTTP status code 418. I am a teapot. It was actually an April Fool's joke many, many years. It actually made it into the HTTP spec. So just to kind of keep things so we're not like I'm doing 404, you're doing 404. I just kind of picked something to make it obvious. But in any event, I expect my service to return a 418 back to my consumer because now I'm a provider.
Are you confused yet?
For somebody else. But now my service is actually returning 500. So I'm not even handling the fact that the Wookiee tamer is giving me 404. I'm not even handling that properly. So now my test is broken. So now we got to go in and fix ourselves here. And we're going to do like what everybody always does, right? We put a big try-catch exception around everything, right? Because that's the easiest way to do things. Catch, web application exception. And now I can just say throw new right, now my tests pass, and now let's publish this contract to the broker. So I'm going to publish a new version of the contract. So the same consumer can't publish the same contract over and over and over again. It just won't allow it because once you've published a contract, it's a contract. It's legally binding, just like any contract you would sign on the dotted line. So we got to publish a new version of it. So when we come back to our broker now, you see now we've got a consumer version 2, and we've got a few interactions here. So now you're going to take over, right? And as soon as I switched over here, just so you see it's already failing, it's already pulled the new contract, and the test's already failing. And if we come back to the broker, the provider's already said, no, I don't know what to do here. I'm broken.
So now we've got the sort of the view that the system is broken. Oh, yeah.
The other way.
Other way?
Yeah. One more.
One more. Ah, nope.
One too many.
One too many. Cool. So now I had, my behavior had been that if I couldn't find a Wookiee in the color they were asking for, I did this nice fallback. Apparently my code isn't good enough and they don't want a fallback. They want me to return a 404. So I know how to do that. So I will instead return null. So now we're good.
Are we?
Well,
the test is still broken.
No. Okay, so we're not good. So the problem is I was returning null, which I thought would trigger a 404, but actually, although it's on that sort of thing of like, okay, something's not right, but it's actually a 204, not a 404. So I could try and change my code to return a 404, but that's kind of hard. So instead, what we could do is we could say, like, look, can you just like change your test to match reality? Because I'm returning a 204. That seems good enough to me. So my job here is done. Now it's your problem.
Does anybody really care, 204 versus 404? Meet me, if we can have a couple drinks later, I can explain to you why 404 is the right answer. But for the
code is good enough.
For the sake of a demo, so what I'm going to do, like every good developer, is I'm going to go back and I'm just going to change my expectation, right? To match, because now I know what reality looks like, so I'm going to just change my contract in my expectation. So I'll come in here, and instead of expecting not found, I'll say I'll expect no content.
Cool. So now we're done, right?
But now my test is failing.
Oh.
Why? Because now my test is still saying, hey, when I ask for a pink fur or to knit a pink carpet, I'm getting a 500 because now the mock is giving me a 204 instead of a 404. And obviously my code doesn't handle it. So you seem like a better developer than me because because my code doesn't seem to is very brittle. So it does, 404, 204, we have to have the conversation, and we actually have to have a meeting, get on Zoom, and figure something out.
Yeah, and so this is the kind of it's quite subtle, this sort of error path handling of we all agree that there shouldn't be a fallback, but then actually figuring out what the right behavior is and making sure that each part of the code can handle it. There was a lot of things that went wrong. And again, this seems like maybe sort of a contrived example, but this actually exactly happened to me.
And me.
Yeah, I was in Copenhagen and I was working on the demo, and I couldn't make my code return a 404, and I was just oh, I'll just return a 204, and then everything else broke, and I was I changed my test to match reality. Why is everything broken? Oh, because it was a mock and it's actually testing the other side. And then Eric was no, you should just return a 404, and I'm no, a 204 is fine, and then So this is the sort of thing that I think you're not necessarily going to discover without this kind of testing, because I would have never, unless I wrote the 500-page design doc, I wouldn't have necessarily gone and said, I care so much about my error behavior that I'm going to talk about 204 versus 404. It's just it's an error, I've handled it, my job is done. And with that, I think we haven't fixed the test, but that was a conversation.
Somebody's got to make a change and fix the test and get out the test screen, but we have fairly good confidence that reality is broken. Right?
Yeah.
That stuff does not work.
Yeah. And
we're sure of it.
Yeah, and that's half the battle with testing, right? Is getting to that you have the confidence that you really don't work. And with that, I think we can stop. Thank you very much. We've got so this is the slides, so that QR code is the slides, and we've got some more resources as well that are in the slides. So there's a more realistic sample application that doesn't have Wookiees in it.
But does have Pact.
But does have Pact, yeah, so you can look at that as well. There's also some InfoQ articles and some books. But I will go back to the QR code for the main slides, because then that links to all the others. So thanks very much, and enjoy the rest of the conference. Oh, sorry, was there questions? No, okay. Oh yes, there's a question. Yeah.
With Pact, can you have consumers on different versions?
Yes, so that, Pact has quite good support for versioning, so you can, that's one of the things that it will allow you to do, is to sort of evolve your system and say, okay, the provider has gone up to version 4, this consumer is happy with version 4, but this consumer needs to stay on version 3, so I have that understanding, and then as long as you actually have something at version 3 deployed, and you've got your mapping and that kind of thing, you're okay. But it does allow you to do that evolution, so you can say, okay, as a provider, even as a consumer, actually, I'm moving the contract forward, and now I can track how my system adjusts to the new version rather than just everything completely breaking.
Actually, you do a great job of solving a testing problem that didn't know existed before. What does it not do that you would like it to do? What's the thing that you see that doesn't exist that you're like?
That's a great question. So one of the things that I'm doing as part of Quarkus is we're sort of doing some Quarkus integration work to Pact. So some of that is just to make sure that Pact works really well with Quarkus, so things like the continuous testing. But I'm also looking at some of the, with Quarkus, we try and do developer joy. So I'm can I bring some more developer joy to Pact? Because one problem I see with Pact is that it can be hard to understand. So if you look at Pact examples on the internet, sometimes what they'll do is they will end up writing a test that tests the mock. So in Eric's case, he would write a test that would say, okay, my mock is going to return me brown, and now I'm going to check that I got brown from the other end. Well, you don't need to check that you got brown from the other end, because you just wrote the mock to say you got brown. What you need to do is check that your code can handle brown, which it probably can, but check that your code can handle the 204, which maybe it can't. It can also be hard to understand the error messages sometimes. So the provider error messages are usually really clear to say, okay, I expected this, I got this. On the consumer side, usually what you'll get as an error message is, I expected this to happen and it didn't happen. And then you're like, well, yeah, but okay, but
why?
What could you tell me what did happen? But it's that challenge of it didn't happen. All I can tell you is that it didn't happen. So that I think is sort of an area for improvement. I'd love to see as well, long answer, there's I think it's coming, but the Pact specification is quite different from OpenAPI, but because OpenAPI is such a universal standard, I think hopefully we'll see some more integration and interop between those two so that you can have a bit more leverage what you already have in Open API with Pact.
And one thing that I submitted to them that they fixed, because when I was trying to work on a demo, is what if my service has multiple providers? And in the course of like one business transaction, I need to talk to 5 different services. Writing the test for that in Pact was kind of non-trivial. They've since fixed it after I gave them a PR and filed an issue, said, hey, it would be much, it's a real use case that this one test might need to interact with 5 different providers.
Yeah, which you can totally see on the Netflix diagram, right? Like the reason it looks like that rather than a 2-meter long string is because things do talk to multiple services. Yeah.
I think the provision consumer are asynchronous.
It does, yeah. So yeah, we showed, the question was if the user, the consumer and provider are asynchronous, is there Pact support for that? Yeah, we showed the REST scenario. There is also async messaging. And one of the things that they've done in the recent version of Pact is they've made it pluggable. So, because I think people kept going to Pact and saying, I'd really like it to support Kafka. I'd really like it to support gRPC. And eventually they kind of went, look, we'll just make it pluggable. You write the thing that handles gRPC. So that's, yeah, now it definitely does gRPC and async messaging and REST, and it's pluggable. So if you have some other really weird protocol, you can just write the plugin and then it will support it.
WebAssembly.
Web
3.0.
Yeah.
Any other questions?
Nope. Excellent. Thank you very much. Enjoy the rest of the conference.